All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. For the factoring, you're going to want to do remove, replace, reduce. And so when you remove the 4, you'll have x squared minus 12x plus 36. And then when you factor it, you'll replace the 4, and you'll have 4x minus 6 times 4x minus 6. And then these will both reduce by 2, so 2x minus 3 and 2x minus 3, which you can also write as just 2x minus 3 squared. All right, so we are looking for, to the nearest 0.1 inch, how many inches apart are the tips of the blade? We know that the length of each of these is 5 because it's a circle and the radius is 5. And then we're looking for the distance here. So I'm going to split this into, this 120 is going to become two 60-degree angles. And then this is a right angle, and so this one is going to be 30 degrees. And so if I'm looking for this length, you can do sine of 60 is x over 5. And so x would equal 4.33. And then to find the total length, you would multiply that by 2, which would give you 4.66, which rounds to, I mean not 4, 8.66, which rounds to 8.7. So that would be how far apart your blades are. All right, so now we're going to be looking at lesson 40. We're going to look at the laws of logarithms and the properties of inverse functions. But before we do that, you're going to have your second trig quiz. So y'all pause the video and get everyone a trig quiz. Put it face down on your on your desk, and then whenever everybody's ready, y'all unpause the video and I'll get the timer started. Okay, on your mark, get set, go. right, so y'all need to be putting your pencils down. Y'all go put it in the basket and then get your notes out so that we can go over lesson 40. Once y'all are ready, y'all can unpause the video and we'll get going. So we're looking at lesson 40, laws of logarithms and then properties of inverse functions. So hopefully after this lesson, you'll understand how to use laws of logarithms and the properties for inverse functions. So we've got 3 laws for our logarithms. One's the product rule, one is the quotient rule, and one is the power rule. If you have a plus sign in between them, you can multiply the m and the n. That's why it's called the product rule, because you multiply them. If you have a minus sign between them, then you're going to divide m divided by n. And then for your power rule, if you have an exponent, it can come down in front. We've gone over those before, but now we're going to practice actually using them. So this is the first example. So we have a plus sign here. So since there is a plus sign, that means that we can combine these into one by taking the 4 and the 6 and multiplying them together. So 4 times 6 would give you 24. Okay. From here, now that we have one log on each side of our equation, we can actually cancel the log base a, so that we just are left with 24 equals x plus 4. And then if you solve for x, x would equal 20. Now the only thing we have to check, our argument, which is where this 4 is, where this 6 is, and where the x plus 4 is, they always have to be positive. And so if we plug in x plus 20, is this a positive number? They all are, so then this is our answer. If it's not a positive number, then your answer doesn't work and you would have no solution. Okay, we're going to look at another one. This time, we have a minus sign here. So the way that we're going to combine them is to divide. So x plus 6 divided by x minus 1. And then from there, the log base 4s can cancel on both sides because we have one log on each side. You can't cancel them up here because you can only do it when you have one log equal to another log. And so x plus 6 over x minus 1 equals 5. After that, we're going to cross multiply. So we'll have x plus 6 equals 5x minus 5. And then I can subtract x to make that 4x and add 5 to make that 11. And so x would equal 11 over 4. And then we need to check and make sure. Is 11 over 4 plus 6 positive? It is. Is 11 over 4 minus 1 positive? It is. And then this one was already positive. So this is our answer. Okay, so that's how you would use the quotient rule for your logarithms. Now we're going to look at the power rule. We have a number in front of our log, and so what we can do with it, it can go to the exponent back here. So instead of 3 log base b of x, we can say log base b of x to the third. And then that's going to equal log base b of 8. And so now that we have one log on each side, you can cancel the log base b's to make x cubed equal 8. And so if x cubed equals 8, take the cube root and x would equal 2. And the only x we have here is right there, and if you plug it in, that's positive. So x equals 2 is our answer. And so that's how you can use your 3 different rules. Sometimes they'll combine them into multiple, where you have multiple parts that you'll have to do. You may have to do the power rule and then the product or the quotient rule, and that's okay. But that's how you use each of the 3. The goal is basically to get one log on each side of your equation. Okay, so so let's look at one more. So we again have a number in front of our log, and so this 2/3 is going to come up here to the front, to the exponent of the 64. So we're going to have log base 12 of x equals log base 12 of 64 to the 2/3. And then the log base 12s cancel, and so x equals 64. And instead of saying to the 2/3, you can say the cube root of 64 squared. So the cube root of 64 is 4, and then 4 squared is 16. So x would equal 16. And it's positive, and so we can plug that in for x. So x does equal 16. Okay, so that's how you use your laws of logarithms. They're not terribly difficult, but you have to make sure that you use them appropriately. You can't just cancel, go back to the first example. You can't just cancel the logs back up here and say 4 plus 6 equals x plus 4. That does not work. So don't try and just cancel them until you have one log on either side. Okay, so now we're going to look at inverse functions. So your functions are defined to be inverse functions if when you compose f of g, you get it equal to x, and if you compose g of f, it equals x. So we want to show that these are inverse functions by computing their compositions. So we're going to do f of g of x, and we're going to do g of f of x. And it says that they are inverse functions, and the reason we know that it says show that they are. If it said prove that they are, or determine if they are, it may not. But since it says show that they are, we know they are going to be inverse functions. So if I put g into my f function, I'm going to say 1/3 3x plus 9 minus 3. And then we're going to simplify this, and it should equal x. 1/3 of 3x plus 9 is x plus 3, and then we have minus 3, and so that does equal x. Over here, we're going to do 3, and then 1/3 x minus 3 plus 9. And if you distribute, you get x minus 9 plus 9, which is just x. So this would be all you would need to do to show that they are inverse functions. Okay, so we're going to try one more example. We want to show that these are inverse functions. So again, we're going to do the composition, and we want to simplify, and we should get x. So if we plug g into our f function, we're going to have 1 over, our x is going to become 3x plus 1 over x, and then minus 3. And then from there, we're just going to have to simplify it. So the common denominator would be an x, and then we'll have 3x plus 1, and then minus 3x. This will simplify to 1 over x, and so the reciprocal of this would just end up being x. So that one does equal x, so we're on the right track. Now we have to do g of f of x. And so instead of x, we're going to replace it with 1 over x minus 3. So you have to plug that in for both of your x's. And most commonly in this part is people only plug it in for one of them, but we have to plug it in here and here. So now we distribute, and so we'll have 3 over x minus 3 plus 1 over 1 over x minus 3. And then in the numerator, we're going to make a denominator of x minus 3. So we have 3, and then plus x minus 3. And then from there, we will have x over x minus 3. And then we can multiply by the reciprocal of the denominator, which gives us x. And so all of that would be your answer. So on the test, when it says determine if they are or show that they are, basically what you're going to do is show your work. And then you can say see paper or see scratch work. to show your answer. But that's all you have to do on those. You just do both of your compositions, and if they both equal x, then they are inverses. All right, so your homework, you do get to omit number 27, and then your third trig quiz is going to be with lesson 43. So it's going to be identical, 5 minutes to work through it. So make sure that y'all study for that and do your homework.